this video, we're going to talk about kinematics practice problems. In a previous video, I talked about how to derive the kinematic equations, and I wrote them out here for you. If this looks somewhat foreign, then I encourage you to go to the previous video and try to understand that before watching this one. So the four kinematic equations: V final equals V initial plus acceleration times time. V final squared equals V initial squared plus 2 times the acceleration times displacement. Displacement equals 1/2 V final plus V initial times time. And lastly, the displacement is equal to initial velocity times time plus 1/2 times the acceleration times time squared. So looking at the first question, it says a car moves at 1.5 meters per second, accelerates at 2.5 meters per second squared. How fast is it moving after 5 seconds, and how far does it travel? So the first thing I would do here is notice that we have initial velocity and we have an acceleration and a time. So with that, if you look at the list of equations we have, it looks like we could probably use this one. Pretty simple. So let's try it. V final, I'll rewrite it down here, is equal to V initial plus acceleration times time. So if we're trying to find how fast it's going, that means we're solving for V final. And next step is just to go ahead and plug in all the values we are given. So 1.5 meters per second is the initial velocity, plus acceleration 2.5 meters per second squared times time, which is 5 seconds. If you do that math, you should get 14 meters per second. It's a pretty simple start. That's part A. Part B says, how far did it travel? So now we're given, or not given, I guess we solve for an additional piece of information, which is the final velocity. So we're given the final velocity here, the initial velocity, the acceleration, and time. So using that information, we can go several ways. Let's see, let's choose green. We could use this equation. V final squared is equal to V initial squared plus 2 times the acceleration times delta x. Let's do that one first. So if we were to do that, we would just plug in what we know. So 14 meters per second whole thing squared is equal to V initial squared plus 2 times the acceleration times delta x. That would be the thing we're solving for. If you were to solve that and isolate x, you should get 38.75 meters. Now, that's not the only way we can solve this, right? Because we have multiple equations that have the same variables. So let's try another way. We can also use this equation because it gives us the opportunity to solve for the displacement by using time, initial velocity, and acceleration. We know the initial velocity. We know time. And we know acceleration. If you do the math, that should give us the same answer, 38 0.75 meters. Let's take a look at the next problem. So we have a mass of a truck is 50,000 kilograms and it's traveling down the highway at 27 meters per second. There's a deer 0.111847 miles down the road. If he is braking at 1.5 meters per second squared, will the driver be able to stop in time? So we're given a very specific distance between the deer and the truck going down the highway. So if there's a way we could solve for the distance it takes to brake at the acceleration that we're given in the problem, we should be able to compare the distance we solve for with the distance we're given in the problem and see if it's greater or less than the value we're given. If it's less than the value, then it means that we can stop in time, right? We'll stop before the distance between us and the deer. If it's greater than that value, unfortunately, we will not be able to stop in time. So let's think about how to go about solving for the distance. If we look at our equations here, we have 4 kinematic equations, and 3 of them include a variable for time. One of them doesn't, right? One of them just has the final velocity, initial velocity, acceleration, and displacement, which is what we want to solve for. So it seems to me that we are going to be using this equation. That did not work. It's okay. Rewrite it. So that equation is v final squared is equal to v initial squared plus 2a delta x. We're not given the final velocity explicitly, but if you know that it's braking to stop, then we know that the final velocity is going to be 0. We are given the initial velocity. It's 27 meters per second. We're given the acceleration. We're told that he's braking at 1.5 meters per second squared. But while it may be tempting to write 1.5 where to substitute it for a, you have to realize that acceleration is a vector. So it has both a magnitude and a direction that you need to specify. And since it's braking, our direction is going to be negative. So you actually need to write negative 1.5 meters per second squared. And we're solving for displacement. So what you want to do is isolate delta x by subtracting this quantity from both sides and dividing by 2 times 1.5, and you should get this number. But that's not the answer. We need to compare this to the distance that we're actually given, which is 0.111847 miles. So one thing that's very important to note here is that a lot of professors and teachers like to switch around units to kind of throw the student off. So you want to really look out for that in your kinematics problems so you can convert between units if you have to. So using dimensional analysis, we know that we can figure out the conversion between miles and meters. So we're given this distance, 0.111847 miles. So you're going to want to convert that to meters by using this conversion factor. If you solve that, you're going to get 180 meters. So clearly we see that 243 meters is greater than 180. So Unfortunately, it will not stop in time. Hopefully that video was helpful for you. If it's a little confusing, I encourage you to go back and rework the problems by yourself and see if you get the same answer I did. And thank you for watching. If you found this informative, please like and subscribe. Thanks.